Okay, guys, so why don't we continue our notes from last time? Why don't you copy these directions, por favor? And let's try two examples here today. So the directions. Convert the given complex number into polar form. So example A, let's go with this one here. Negative 10 plus 3i. So right now, this is a complex number, but the current form is what we call rectangular. But they want us to convert it into polar form. That's the goal for this problem. We want polar form. So recall polar form looks like this. R cosine theta plus I sine theta. And what we have to find is R, and we have to find theta. Once you know R, you put it there. Once you know theta, you put it there, and then you're done. So to begin this process, what we can do is we can graph this on the complex plane, like that and like that. So this point, it's basically like negative 10, comma, positive 3. So let's pretend that that is up here, where this is negative 10 and where this is positive 3. We can even draw a triangle like we did last time, like this. All right, like that there. Where we know that this is 90 degrees, and we know that the hypotenuse, okay, the hypotenuse is called R. And whatever R is, we'll put it right there. So if you go Pythagorean theorem with parentheses around the negative 10, you will find that R is the square root of 109. And you want to leave it like that. Leave R the square root of 109. So let's get this out of the way. So we know that R is the square root of 109. All that's left to find for this first example is theta, our angle theta. And recall that our angle theta, I will draw it here for us in the color green. Boom, there it is. That's theta, okay? We have to find theta. It's bigger than 90, but it's less than 180. So to find theta, what we need is maybe some other purple angle, that's called, let's call it alpha. Let's find alpha, and then we can find theta, and then we'll be done. So let's see if you agree with me that tangent of alpha would be opposite over adjacent. See if you guys agree with me. That tangent of alpha would be 3 over negative 10. All right. And now to get alpha alone, we can go tangent inverse of both sides. Tangent inverse, because these cancel, and that isolates theta. And on a calculator, if you round it to like the nearest degree, if it's negative, just make it into a positive. It's about 17 degrees for alpha. Yeah, I know the calculator might have said negative, but just take the absolute value to the nearest whole number. 17 degrees. That's going to be alpha, right? 17 degrees. So let me get this out of the way. We've just discovered that this is 17 degrees. But how much is theta? Well, recall that a semicircle is 180. So what we have to do is go 180 minus 17, and that's 163 degrees for theta. And that goes back up to the main problem. So final answer here in blue. Let's continue with blue. This would be cosine 163 plus I sine 163. And box in your answer. Done, 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 100%. We went from complex rectangular into final answer complex polar, where this is r, the hypotenuse, and theta was 163. And as we said, 163 is more than 90, but it's below 180. See that? So it's all perfect. It all works out nicely. Okay, one more, guys, and that'll do for this video. And then we'll continue on Monday when I will hopefully be at 100%. All right, let's see. So example B, let's go with 5 square root 3 minus 5i. Let me write that a little bit smaller, like that. So this number is in rectangular form. And basically the point that you plot is 5 square root 3 comma negative 5. And that would be in quadrant. It looks like this would be in quadrant 4, right? This would be in quadrant 4. So let's see. Let's emphasize quadrant 4. Just put a dot anywhere there. It really doesn't matter. And then draw your regular triangle. Like that, and like that, and like this. Where this is 5 square root 3. This is negative 5. And in green, we have this here. That's going to be theta. And we do need a purple or a pink hypotenuse, which is going to be r. And then we do need, let's go with like a baby blue. Let's go with purple, actually. Let's go with a purple. Let's go with a purple alpha. So first things first, let's find r. So we can go 5 square root 3 squared plus negative 5 squared equals r squared. And then on a calculator, guys, make sure you use parentheses, because without parentheses, we're going to mess up. So let's see. It should be 10, actually. If you do the Pythagorean theorem with a calculator, you should get 100 squared, and then square root, you should get back 10. So we know that the r is going to be 10. Now, let's find alpha by first finding, or let's find theta by first finding alpha. So let's see. So we said that this is alpha. We said that this was 10. And for now, right, we have theta here. The radius, or the r, is 10. Let's find alpha. And once we know alpha, we can find theta. And you know that theta is going to be more than 270, but underneath 360, somewhere in there. So let's use tangent again. How about we use tangent of alpha equals opposite over adjacent. Let me grab my calculator and then go tangent inverse the way you did earlier. And let's see what we get. We get exactly 30 degrees, right? If you take the absolute value of the negative 30, we should get positive 30 degrees. 30 degrees for whatchamacallit. 30 degrees for alpha. 30 degrees for alpha. Okay, so once you know that alpha is 30 degrees, then how much is going to be theta? Well, theta is almost a complete spin back home, but it's a little bit smaller. It's 30 degrees smaller. So you have to go 360 minus 30, and that gives you 330 degrees. You see that? 330 degrees. So that's going to be our theta. So why not final answer? Final answer down here, let's go in pink. Final answer in pink, we have 10. And then cosine 330 minus I, or plus I, sine 330. So R is 10, and then theta was 330 degrees. And again, bubble this in, and this is our final answer. So guys, When we meet in class on Monday night, we'll continue this notion with section 10.3, which is our last section of the semester. So if you have any questions, please let me know. But if not, I'll see you guys all on Monday night.